So my topic today is fancy fisheries models overestimate productivity of depleted stocks. That is something that we have suspected a long time, and actually we were working on a presentation, on a paper that shows that, but we were overtaken by a group in Australia. So they basically published in Science a paper called Stock Assessment Models Overstate Sustainability of the World Fisheries. And Science was so kind then to ask me and Daniel to write a perspective about that, which we did. And while the paper by the Australian colleagues was very elaborate and mentioned things in passing, we kind of took out what was really important and, made a fuss about that in a way. And in Germany, actually, that had over 200, close to 300 citations in the media, which my media people at GEOMAR were kind of surprised with the impact. So here we go. The first thing that we put into perspective of their finding is, what does it mean if the size of fish stocks is overestimated? Because that's basically what they found. They found that if you have a time series of stock size, then the last 2-3 years were too high. They were corrected later on so that the older years were more or less correct, but the recent ones were always wrong and always too high. And they gave roughly a very conservative figure of 30% too high. And they mentioned in passing that that would also mean that the graph that you're looking at now would have to be corrected, because the overfished section there actually should be larger by at least 30%. That would give a line somewhere here, and it would mean that not 1/3, but roughly half of the fish stocks globally are overexploited. Also, there's another little thing down there where you think, okay, the underfish stocks are increasing or are doing better, or we're on the way right. But that's exactly what they found is the overestimation in recent assessments. So what we would expect is that this thing disappears for 2021 in 2-3 years, but there will be a new one for 2023 and 2024. See, so it's a moving, always the recent ones are too optimistic and corrected later when new data come in and force the models to become more accurate. So that was the first thing that we put in perspective out of that paper. The second thing is something they called, phantom recoveries. And we looked for a simple example in the data that we have hand. They also looked at about 40 stocks from the ISIS area. They looked at 230 stocks globally, including 40 or 42 from the ISIS area. We picked one of those and had a closer look. This is the North Sea sole. And the blue line is the latest assessment in 2023. Okay. But if you had looked at the assessment of biomass in 2021, you would have seen the red line. If you would have looked at the assessment in 2018, you would have seen this green line. So this is what they call phantom recoveries, which completely disappear in only a few years later, because you see this recovery in 2021 is completely gone in 2023. Okay, so phantom recoveries. Now, that you can think, okay, well, tough luck, bad or whatever, but what it means is more important, because the catches that the managers then decided upon, the allowed catches, remember this Northern Europe, where we have total allowed catch set by politicians, they looked at this biomass in 2018 and allowed very high catches. They looked at this biomass in 2021 and allowed very high catches. And they will look at this biomass in 2023 and again allow higher catches when the stock may actually be down here if we look at it 3 years in the future. Okay, if we look back at it from 3 years in the future. So this overestimation of biomass is really, really a major problem. and can be one of the main reasons for overfishing and us losing stocks. And why is that so? Now, the stocks that they looked at, the 230, were the largest stocks of the world, mostly in developed countries like North America, Europe, Australia, New Zealand, which had fancy stock assessment models. The SS3 model that many of you know is one of the favorite ones, and there are a few similar ones. And they nicely point out that these models have up to 40 parameters or settings, many of which are, well, not backed by data because we have no data for them, such as natural mortality. Estimating natural mortality in a stock that has been exploited for a long time is extremely difficult. Another one is the famous steepness. As you know, that is how high is the productivity when the stock is small. And again, we have no data then relative to the unexploited size of the stock. And again, we have no data on that. And so if you set a few of these too optimistic, then the whole prediction of these models will be too optimistic. Now, we had our own view of that in a paper that we published last year about the CMSY method that Deng and Daniel mentioned earlier. And there we were forced by the reviewers actually to prove that our two-parameter model, which is the yellow one that you see here, the CMSY model, actually comes to similar supposedly true results as the fancy four-parameter models, which is the red line here. This red line is based on 14 stocks that had been assessed with the SS3 model. And they were all that we had the data on, so it's not a selection of those that went wrong. And the data in the background actually, I call them model-independent data, because they just present catch relative to the maximum catch reported for the stock, and stock size relative to the maximum stock size reported for that stock. Okay, so there is no model implication here, really. And because for stock size, we also use CPOE as a proxy. So the CPOE currently relative to, at the year that is reported, relative to the highest CPOE ever reported. And that then gives the background scatter cloud. And you see that our yellow line nicely traces the highest density of points, whereas the supposed golden standard 40 parameter models completely overestimated here the productivity at small stock sizes. Okay, meaning if ever a stock had the bad luck to get into this area here, then they completely overestimated what catches it could still support, and these catches were much too high and would basically crash the stock. Okay, so that's the story there. And now I give you a peek preview of the paper that we were working on when the Australians kind of hit us from the side, if I say so, because we had found similar things and we're working on those, but let's give you a view. Our paper was focused on actually how is management working in the EU. And as you know, EU has a complicated management system of fisheries. It starts with National Fisheries Institute providing data to ICES. I'm talking now of Northern Europe, not the Mediterranean. And then ICES has working groups and they do stock assessments and do estimate biomass. And based on the estimated biomass in the next year, the TAC year, they give then catch recommendations. Okay? Catch advice to the European Commission, GEOMAR, which pays them for that, a few $1 million per year. Now, the EU Commission then makes a catch proposal, how high the total allowable catch for next year shall be, and then the Council of Ministers in charge of fisheries, mostly our agriculture ministers, decide the legal total allowed catch for the next year. And that then is, how it works. Now, and actually that is a question, how is that working if we look at real data? Now, I picked one of the stocks. We deal with all stocks in the Baltic for that paper. as an example. I pick one of those because my time is very limited. So I pick the example of Western Baltic cod and see what it's doing. Now here in this graph, we have now a time series of data from 2003 to 2022. And the blue line is the observed biomass, right, from surveys and CPU and what have you not. And you see it's declining for 20 years, which in itself is a disgrace to fisheries science, but that's what it is. I also show here the safe biological biomass. If the stock falls below this line and you wonder why the hump is there, ask ICES, not me. If the stock falls below this line, then the recruitment, the reproduction is in danger. And the further you go down, the further in danger it is. And then there's a line on top here, which is actually the stock size that is required by law. And that is the stock has to be at least large enough to produce the maximum sustainable yield. That's where the stock should be, but you can see it's not. And yeah. And now there were several warning signs because of that already. In 2003, the stock was already below the size that can produce the maximum sustainable catch. Here in 2009, it was falling below, it was falling outside of safe biological limits. So in this case, it would have been a small reduction in catch that would have brought it back there in 1 year. Here in 1 year, it could have been there. Cod, when they are 3-year-old, double their weight, their body weight in 1 year. Meaning, since the stock is mostly consisting of 3-year-old cod, in 1 year they could have been twice of this, way up in the right thing. Okay, they didn't do that. Here, it's basically where B-lim is, and it's falling below B-lim. Again, another very severe warning sign. Now there's a very high probability that recruitment will be too low or not at all, and they ignored that. Then, of course, here the stock now is collapsed, and you should stop all fishing, but fishing continues as long as the fishers declare them to be bycatch. Okay? So this is the situation of the stock. Now, how was it managed? ICES estimated that about 21 to 24% of the biomass, that's our blue line, can be taken out sustainably year by year. And I put that here as a green line, okay? This is the 21 to 24% of the biomass that is there. Okay? You can take it out year by year and then it will be regrow and then the stock size basically will remain or increase slightly. And however, this here is the catch advised by ICES, the purple lines. And you see it is about twice up to 3 times as high as the green 21% that ICES explained to be the maximum sustainable. Okay, the maximum you could take out. They say 21 to 24%. This is the green line, that is the 24%. This here, as you can see by your eye, is 50%, is kind of 60% of the biomass that was there. Now, how can that be? See, in the past, I also looked mainly whether ICES recommended the right percentage in a way. That's the famous F turned into percentage of the biomass. And since that wasn't the right area, I was not too much concerned. What I did not realize is this. These points here in the sky, okay? This is the biomass that ICES predicted for the TAC year to be there. This is the real biomass, right? In hindsight, 3 years later, they knew it was this size. But this is what they predicted, on which they then based their catch recommendation. So it's roughly 20% of that value. And that is how they get to this catch advice based on completely wrong biomass predictions. And there are not, if you look at the true biomass here, 20% or 30%, as the Australian colleagues found on average. These are 100% and more wrongly predicted biomass with the then wrongly set recommended catch. Okay, the next step in the process is now the European Commission, DG Mare, making their catch proposal. These are the black dots here, the black circles. is the catch proposal that GEOMAR made based on ICES advice. And you see it's about 100% of what was there. It's even if you look at it, remember this is the biomass, adult biomass. The catch proposed by GEOMAR was higher than the actual biomass. Again, how could that be if you look back? Because the biomass that ICES had told GEOMAR was there was higher. So they were below the predicted biomass, but in hindsight, way above the real biomass in many years. And certainly they were even above the much too high catch advised by ICES. Okay, so now this is the last but one step in the management process. And the next step is then what do the ministers decide? And this is now the dashed line, the red dashed line. You see they mostly follow the GEOMAR, the Commission catch advice. Okay. So where is the problem? It's really ICES and it's GEOMAR, both of them giving much too high catch advice. And now still one more step that I want to share with you, which is what did the fishers do? Okay. And that's here, the total catch is this red bold line. And you see the fishers could not catch more than was there. The blue line, remember, is the biomass of adult fish, and which they were supposed to catch. Many of them were immature, but anyway. And you see they could not take more out than 80 to 90% of what was there in mature fish in the water. So the fishers actually stayed way below the allowed catch, except for the years when it was really, really already on the way to nowhere. Meaning it is not the fishers really that killed the fish, and yes, they caught them, but it was the wrong advice given by the system, the very, very wrong advice that actually urged the fishers, why don't you take more? Look what they allowed them. Wrong incentive, wrong advice, everything wrong. So this actually I showed at a meeting in Brussels where the head of ICES ACOM committee was there, where a lead person from GEOMAR was there, and asked them why. And yeah, the answers were mostly excuses anyway. Now, if this is the thing, what is going wrong? Here's my take on it. Yes, we will still continue to get data from the National Fisheries Institute. There may be problems with the data. People that are in the room, I know the problems very well, but I assume for the time being that the data are more or less okay. But then ICES gave too high catch advice, and then the Commission made a too high catch proposal, and then the Council said too high catch. But why did they do that? And my take on it is that the national experts that make up the ICES working groups basically had an expectation, I say carefully, from their home offices to make the allowed catches as high as possible. The Commission, and she said that in the meeting in Brussels, is under a lot of pressure from the member states. They get calls from head of governments to say, okay, next year we need so and so much catch in tons, much too high. So a lot under pressure from the member states to set catches as high as possible. And then the Council of Ministers, these are the representatives of the member states. They want to go back and tell their fishers, I was fighting for you for the highest possible catch, or the reductions are not as strong as the Commission wanted to do. I made them, and so on, all supposedly to help the fishers. Now the results of that are well known. The fish stocks are gone. Now, after looking at this for 20 years, I'm being frustrated a lot. What is my idea on how this can be fixed? Actually, I think this national influence has to go away. This is the core problem. There's much too strong, short-term, very short-term, short-sighted, no clue of anything influence on fisheries management for the highest possible catch right now, and that has to go. So my suggestion is to do away with ICES, and all the national institutes that advise on fish, not on data collection, data that we need, and instead have an independent new agency similar to a central bank that is independent of any political influence as much as that is possible, and rather applies a few simple rules like let the fish spawn, keep all stocks above the MSY level that I showed in the first slide, take less than MSY even you are above that level, never take more than MSY, and let the low trophic level species like the anchovies, the sardines, the herring, the spread, grow and have high biomass because they are extremely important for energy transfer from low to higher trophic levels. Simple as that. Okay, and that is my presentation. Thank you very much.